All right, gentle people, we are back. It's been a minute. I took a bit of a break, but we're picking up where we left off and we're looking at simultaneous equations, right? This is following up from what we did on with factors and remainder theorem and polynomial division. So we're here now, right? And some of you may have covered this before, but we're going to kind of do a quick recap so that you're comfortable with the process that we're about to use. All right. Now, what is simultaneous equations? Right. So as you can see before, you have two equations. You have 2x plus 3y is equal to 7, 3x minus 4y is equal to 2. And these are examples of simultaneous equations. These are equations that at some point will meet if you were to graph them. And that point where they meet, that's a solution that satisfies both equations. There's a value of x and y that makes 2x plus 3y equal to 7, and at the same time makes 3x minus 4y equal to 2. Our job is to find that value, and there are a couple of ways to do that. Now, before doing that, what you'll notice is that there are two variables. Right? We'll have 2x, we have 3y in the first equation, and the second equation we'll have 3x, and we'll have negative 4y, right? Now, normally, and I say normally, before this, you'd have had equations that only had one variable. That's probably what you'd have encountered. And so we might have seen something like 3x minus 5 is equal to 7. In an instance like this, not an uncommon case, you have one variable, and so you only need one equation to solve this. Yeah. So the process here, you already know it. We'll have 3x minus 5y is equal to 7. We need the value of x here, right? And to find the value of x, we're going to need to get the term on its own. Let's determine x on its own. Now, determine x is 3x. Now, to get that on its own, we need to get rid of that negative 5. And if I add 5 on the left-hand side, I balance and I add 5 on my right-hand side, right? Because what I do on the left, I do on the right to ensure that I haven't changed the value of what I have initially. So what I end up with now is 3x is equal to 12. We're almost there. Now we have the term in x, but we don't have 1x, and 1x is what we want. We don't want 3x. Now, common sense tells you if that 3 of something is 12, then 1 of that thing is 12 divided by 3. And we know that to be the case because we can divide this through by 3 to cancel that coefficient here. And whatever we do, we're going to do on the right-hand side. Yeah. So we end up with x is equal to 4, and we're good. Yeah. That's our solution. And we're able to do that because we only had one variable, and so we only needed one equation. In any instance, such as the ones we're going to discuss today, where you have two equations, you're going to need, two variables, you're going to need two equations to solve them. And that's where that whole discussion of having simultaneous equations occurs, because once I find a solution for the top or the bottom equation, I'm simultaneously finding the solution for the other equation. No, there may be 4 methods of doing this that you would probably have covered if you've done this topic before. We can use what we're going to discuss today, 2 of which we're going to discuss today: elimination and substitution. Those are the ones we'll focus on. The graphical method we'll just kind of pass on. We'll talk about in passing. And the matrix method we won't cover today. We probably will have covered it in another course, but that's for another day. Right. Now we're going to start off with our elimination method, and then we'll go to substitution, and we'll do maybe 2 examples to kind of get you acclimatized. There are going to be more questions on the website, and there's a link to the website on the channel, so you should be able to get through and practice, because it's important to practice. That's where you kind of cement all of these concepts. Now let's get into it. Our first method 1, elimination. And as the name suggests, we're going to eliminate one of the 2 variables, whether it's x or y. The decision on which one to choose is up to you. As we kind of practice these questions, our job will be to kind of show you which one might be best in terms of what will work out as the easier route for you, the more effective and efficient route. However, if you choose not to use that route, and you might be under pressure and you're kind of worried, don't worry, because it doesn't matter which variable you choose. If your mathematics is correct, if your process is correct, your answer is going to be correct as well. So the heavy lifting is understanding process. Then we can worry about being effective and efficient. Now, for our intents and purposes right now, we're going to choose to eliminate the term in x which for the first equation is 2x and for the second equation is 3x, right? Now, elimination is really just I'm going to add or I'm going to subtract to cancel one of these out. Now, if I add these two, 2x and 3x, I get 5x. There's no cancellation there. I need it gone. I need 0x, which is 0, right? If I subtract one from the other, 2x subtracted from 3x is x, and 3x subtracted from 2x is negative x, not 0, right? That doesn't work. So what we're going to do, we're going to multiply. In this case, you have to multiply both equations by a constant to get the coefficients of x, since we chose x, to be the same. So in this instance, if I choose to eliminate x, elimination, choose, I should put choosing x, right? I'm going to multiply this first equation by a constant. In this case, I'm going to choose 3 because if I multiply 2x by 3, I get 6x. But then I have to multiply everything by 3. So this becomes 9y because it's 3 times 3y. And 3 times 7 is 21. All right? We can call this equation 1 still. I'll call it equation 3 for the sake of us tracking what we're doing, right? Now, I'm going to multiply my second equation as well. But if this is 3x and I need it to be 6x, I'm going to have to multiply this by 2. So 2 times 3x is 6x. 2 times negative 4y is negative 8y. 2 times 2 is 4. And just for continuity, I'll call that equation 4. And now I have my two equations. Now they're roughly the same equations because I multiplied each by I think they're a number, a factor of 3 for the first equation and 2 for the second equation. And so the relationship between each of these terms is still the same, all right? Because each term has been multiplied by the same number. Now, we're going to eliminate. And remember, I told you, elimination is literally just an addition or a subtraction process, yeah? Now, if I add these two, 6x and 6x, I get 12. I'm not adding them. I'm subtracting, right? But I'm going to just put everything in a bracket here and subtract vertically, yeah? So it's going to be 6x minus 6x. It's going to give us 0, right? 9y minus a negative 8y, which is the same thing as 9y plus 8y. 8 and 8, 16. So 8 and 9, 17y. And 21 minus 4, which is going to give me 17. Which means, this implies, y is equal to 17 over 17. I'll write it. And then we'll scroll up a bit. If we can, give it a second. You know how this works with me. All right, but I know you kind of know it takes a second or two for this thing to work with me, right? All right, scroll up a little bit more because we're at the point where we have y, right? Now we're going to say y is equal to 1. Now remember the equations that we had before. They're not visible on the screen, so let me just see if I can write them back down. All right, so the equations that we had before, if 2x plus 3y was 7, and what was the other one? 3x minus 4y is 2. And I know what y is. I can find x. Now, given or granted, we have two other equations. We did create equations 3 and 4. It doesn't matter which one of these you choose to substitute y into. You get the correct value of x. So I'm going to choose the one that looks easy. I'll choose equation 1. This was 1. This was 2. Substituting. If I'm writing a statement, you don't even have to do this. For y is equal to 1 in equation 1 gives, what are we going to get? We're going to get 2x plus 3 times 1 is equal to 7, right? We're going to get 2x plus 3 is equal to 7. We're going to get 2x is equal to 7 minus 3. We're going to get 2x is equal to 4, and x is equal to 4 over 2. X is equal to 2. So we should be comfortable there, right? Now, what does that mean? What that means is we have a value of x now and a value of y. So for these two equations that we have, what we're saying is the solution is for 2x plus 3y equals 7 and 3x minus 4y is equal to 2, the solution is x is equal to 2 and y is equal to 1. So our solution is 2, 1. These two lines intersect at the point 2, 1. That's the coordinate, right? And you can check it. The good thing about simultaneous equations is when you get your answer, you can substitute back into the equation to confirm. So if this is the case, right, where we say x is 2 and y is 1, then 2 times 2 plus 3 times 1 should give you 2 times 2, 4, plus 3, it gives you 7, right? That works. And in this case, we'll have 3 times 2 minus 4 times 1 is equal to 2. 3 times 2, 6, minus 4 is indeed equal to 2. And we're good to go. So we've proven this to be the case. This works. This has been solved using elimination. Now, what does the other process look like? The other process that we have is called substitution. If I can, I might have to put this on another sheet. So let's do that. All right, so we're going to solve this one on another page. All right, so for the same equation, right, we're going to use the substitution, same two simultaneous equations. Oh, if I can, let me get things situated over here. Substitution. Right, now, writing aside the method, if I have 2x plus 3y is equal to 7 and 3x minus 4y is equal to 2. For substitution, as the name suggests, we're going to literally substitute a value for a term for x or y into the other equation. So let's have to take equation 1. This is my equation 1, and I want to find a term for x. I would say that from equation 1, I can say 2x is equal to 7 minus 3y. Now there's no 2x in the second equation and no multiple of 2x. So I'm going to have to find x. So this means that I have to use x is equal to 7 minus 3y over 2. I'm going to put this into this equation. Now, you don't find a value for x from equation 1 and put it in equation 1. If you do that, you're going to end up with something like 7 is equal to 7, which, while very much accurate, does not move your case forward, right? So if I actually create or find a term for x from equation 1, I must substitute that in equation 2. Do not substitute in equation 1. You're going to be wasting your time and end up with, in this case, something like 7 is equal to 7, which, while accurate, I think you knew before you started working, right? So now that we have a term in x is equal to 7 minus 3y over 2, and I'm just going to write from equation 1, right? Now I must substitute for x in equation 2, right? So that's my job now. I need to put this here in here, and it's doable, and we're going to do it. So I'm going to scroll up a bit. Despite what you believe, I'm getting more adept at doing this, right? So instead of having 3x minus 4y is equal to 2, I'm going to have 3 times 7 minus 3y over 2 minus 4y is equal to 2. And you're going to be like, why would you do that, right? It's not that bad. I know you love fractions. Don't hide it, right? We're going to solve it. You can do it. I believe in you. All of that good stuff, right? So here's our process. And we like to work and keep it simple. This doesn't look like the most simple approach. It isn't. It's not the most ideal, but we're just showing you both elimination and substitution. Now we can make this easy. How are we going to make it easy? Well, I have a denominator of 2 and y'all hate fractions. Let's get rid of it. Let's multiply everything here by 2, right? Of course, messed up my screen just now. Ah, great stuff. All right, I think I kind of have a handle on it. Kind of. I was bragging about how much more comfortable I am with the screen now. And then, great stuff. So if I multiply this by 2, I get rid of the 2 in the denominator here. Now, what that means is that I end up with just 3 times 7 minus 3y, fraction gone, minus 2 times 4, or 2 times negative 4y is negative 8y, is equal to 2 times 2, which I'm sure it was 2 at the end, yeah, is 4. So we're good. So all I have to do is expand and solve. We'll get 3 times 7 here, 21, 3 times negative 3, negative 9y minus the 8y is equal to 4. And we're good at addition, right? We can add negatives here. So we end up with 21 minus what looks like 17y is equal to 4. Negative 17y is equal to 4. And I can get rid of this 21 here by subtracting 21 on both sides. I end up with negative 17y is equal to negative 17, which means for us that y is equal to negative 17 over negative 17. Y is equal to 1. Now, once we know what y is, we can put that in any of the two equations to get our x. It doesn't matter because both of them have the same values of x and y. So we can take the second equation in this case. If 3x minus 4y is equal to 2, and we just randomly chose the second equation, this implies that 3x minus 4 times 1 is equal to 2. 3x minus 4 is equal to 2. 3x is equal to 4 plus 2, which is 6, and x is equal to 2, which we said before, 2, 1. That was the solution that we got initially, right? When we used elimination. We've done this with substitution. We get the same solution, and that's expected because, and we would have discussed this, I guess, somewhat. Pretty sure, did we speak about the equation of a line? If we hadn't, just know that these are both lines, right? Both the 3x minus 4y equals to 2 and the 2x plus 3y is equal to 7. Those represent the equations of lines. And so wherever those lines cross, the values of x and y are going to be the same. When we solve a simultaneous equation, we're finding the point of intersection of our two lines. Right? Once we find a solution, those lines intersect. Those lines don't have the same gradient. All right. So we're comfortable with that to an extent, right? Let's try to knock off 2 questions really quickly. If we can. We'll just do elimination and substitution for both. Call it a day, and we'll probably get back here and talk about simultaneous equations where one is a linear equation and one isn't. Right? We'll have those to look forward to. But not too difficult. Once you understand this, you should be fine. All right, so let's knock these out. So for this next question, we'll have 2x plus y is equal to 5 and x plus 2y is equal to 7. Kosher. This is brilliant. For this question, I would probably, 1 or 2, we can eliminate, we can substitute. Substitution is going to be really easy here because we have 1x as a term here and we'll have 1y. So we could choose to find x and substitute that in this equation, or we could find a value for y, a term for y, and substitute it into the second equation. Either way works. But we're going to start with elimination because that's what we did before. So if I write this in this, let's go 2x plus y is equal to 5. And we have, let me write it like this, 2x plus y equal 5. X plus 2y, oof, horrible, is equal to 7, right? And I'm going to go elimination. All right, we're good. The handwriting gets worse with time. This is my equation 1. And this is my equation 2, right? Now, if I'm going to eliminate I'm going to need the coefficients to be the same. So in this instance, what I can do, I can probably multiply my second equation by 2, right? And that would give me 2x plus 4y is equal to 14. I'll call that equation 3, right? I don't really have to do anything to equation 1. That can stay, all right? Because it already has 2x. And let me just make sure, multiplying this by 2, we get 2x, this by 2, we get 4y, this by 2, we get 14, and this as is 2x plus y is equal to 5, right? So now all we need to do is just subtract, right? So 2x minus 2x dot 4y minus y is just going to be 3y, and 14 minus 5 should be 9. And we're almost done, because this means that y is going to be equal to 9 over 3, which is just 3, right? And if y is 3, we can substitute that into what we had before. And let me scroll this up a bit really quickly, if I can. And the joys of scrolling up, 2x plus y is equal to 5. If 2x plus y is equal to 5, this implies that 2x plus 3 is equal to 5. 2x is equal to 5 minus 3, which is 2. X is equal to 1. So our solution here is going to be 1, 3. And that was via elimination. Now, what does it look like using substitution, right? Light work. And of course, what you can do, you can, if you feel comfortable enough, pause the video here, work ahead of me, always like a really good thing to do, because you can actually then validate your process by looking at what I do next, all right? So substitution. The handwriting. Words cannot express. All right, let's find this back. So our equations were 2x plus y is equal to 5, and the other one was x plus 2y is equal to 7. Do I trust myself that I did the same equation? I'm checking. Okay. Yeah, I'm right to the same equation. I'm good. All right. And we said we're doing substitution, all right? This process is easy because we already have a term in 1y here and a term in 1x or x. So I'm going to just take the term in y just because I can. Y is equal to 5 minus 2x. I now have a term in y I can substitute. And this is from equation 1, so I must put it in equation 2, right? You can write expressions if you need to, right? So what this means is that where I had x plus 2y before, I have x plus 2 times 5 minus 2x is equal to 7, which means x plus 10 minus 4x is equal to 7, which means x minus 4x, which is negative 3x, plus 10 equals 7. We should be okay to this point. We end up with negative, and I'll just check 2 times 5, 2 times that, negative 4. We should be okay. We end up with x plus 10 minus 4x equals 7. X minus 4x, which should give us negative 3x plus 10 equals 7. Negative 3x is going to be equal to 7 minus 10, which should be negative 3, and x should be equal to 1, which means our solution, did we get a solution before? We only have x so far. Our solution will be given by, if we know that y is equal to 5 minus 2x, 5 minus 2 times 1, which is 5 minus 2, which is 3. All right? So our solution, again, is just going to be 1, 3. I'm pretty sure that's what we got before. We can check. We know it is. We're good them ways. All right. So we're comfortable with elimination and substitution in those two questions. We have one last question to look at. One final question. We're almost there, right? And we're going to again go through this process using elimination and substitution. So we're going to start with elimination. We have, of course, we need to solve 2x minus 3y is equal to 12, and 3x plus 4y is equal to 1. What does elimination look like in this case? What are we eliminating, right? Is it easy to see? Well, we have 2x and we have negative 3y, we have 3x and we have 4y. none of those don't readily have the same. None of those have the same coefficient in terms of x. The coefficients of x here are 2 and 3, and the coefficients of y are negative 3 and 4. So we're going to multiply both equations to eliminate, right? Now, in doing these questions, you realize that elimination isn't always the easiest route, but again, all approaches will work if you're doing the right thing. If your math is correct, your solutions will also be correct. So we need to make the coefficients of either x or y the same. There's a negative term here. I'm working with, let's do something different. Let's make the terms in y the same, because we haven't done that before, right? So what I'm going to do is I'm going to multiply equation 1 by 4, right? Because then that will give me a negative 12. So I get 8x minus 12y is equal to, and we're multiplying this by 4, 48. And that's equation, we'll call this equation 3. By now you know the process, right? So for this one here, we're going to multiply equation 2 by 3, and we get 3 times 3, 9x plus 12y is equal to 3. Now, remember, elimination involves either addition or subtraction. In this case, because the signs on both 12 and negative 12 are different, we're not going to subtract. If we subtracted, we get negative 12y minus 12y, which is negative 24y. We're adding these. So end up with 8 and 9, which is going to give us 17x, negative 12y plus 12y, which is going to give us 0. And that's equal to 48 plus 3, which is 51, right? Now, what we're going to do is solve this, because it's almost done now, right? We're going to end up with 17x being equal to 51, which means x is equal to 51 over 17, which should be 3. Yeah, pretty much. So x is equal to 3, and now we need to find a value for y, but we have 2 equations we can substitute this into. I'm going to choose this. I'll choose the 3x plus 4y is equal to 1. Let me scroll this down. If 3x plus 4y equals 1, that means 3 times 3 plus 4y is equal to 1, which means 9, plus 4y is equal to 1, which means that 4y is equal to what looks like negative 8, and y is equal to negative 2. And that means our solution is 3, negative 2. Now we're going to keep that in mind, because we're going to, again, look at this question not using elimination but substitution. So we're almost done. We're almost there. Good job to this point. If you're still with me, you're holding firm. Remember that our equations are 2x minus 3y equals 12, and 3x plus 4y equals 1. All right. What did we say we're doing now? We did elimination within substitution. That's old man brain right there. Yep. And the handwriting devolves as the video continues. All right. So we're substituting. What can we substitute? Again, we don't have anything nice, nothing neat. So we're just going to substitute. I'm going to go for the first equation. And I'm going to say if 2x minus 3y is equal to 12, this implies that 2x is equal to, let's go 3y plus 12, right? Which means x is equal to 3y plus 12 over 2. And I'm going to, if I got this from equation 1, I cannot substitute in equation 1. If I do that, I'm going to end up with something like 12 is equal to 12, which, while accurate, does not move your cause forward. All right, good. That's my mantra. I'm saying it. If you go through the question and you end up with 10 is equal to 10, congratulations. You played yourself. If you take it from equation 1, put it in equation 2. If you take the substitution from equation 2, you put it in equation 1. All right. So we'll have a song. You can work with it. So what we're going to do is we're going to take this term in x, we're going to drop it in here, and we're going to solve, right? So that means that 3 times our 3y plus 12 over 2 plus 4y is equal to 1. We don't like working hard, we like being efficient, so we're going to multiply this entire thing by 2 because it gets rid of the denominator there, and we end up with 3 times 3y plus 12 plus 4y is equal to 1. We're almost there, people. Daylight, it's almost there. Expand this out, we get 9y plus 36 plus 4y equal 1. We we end up with 9y plus 4y. We should be ending up with 13y, right? Is equal to 1 minus 36. Is that correct? I don't know. So end up with 13y is equal to what look like negative 35. That can't write. So what did we miss? Something went amiss. Let's look. So over here we said 2x minus 3y equals 12. Let me check. And we said 3x plus 4y equal 1. All right, good. So that means that 2x is equal to 3y plus 12. X is equal to 3y plus 12 over 2. 3y plus 12 over 2. We'll put it in here, right? 3 times this. Looks good so far. Plus 4y equal 1. Good. All right, what did we not do? Oh, we didn't multiply by something. So when we multiply this by 2, guess what we never do? Cheese. And then when I have me out here forming a fool. All right. This is the line where it all went nutty. All right, so let's fix it up. This is what you call exhaustion for real. All right, let's get it. All right, so here, let's expand this properly. So when we multiply this by 2, we should have had 3 times 3y plus 12, but we did not. I did not multiply by 2 here. So this should have been 8y, and this should have been 2. Good. Now we're almost done. 3 times 3y, 9y, plus 36, plus 8y is equal to 2. We're almost there. 9 and the 8. Now we look like we're playing with fire, right? So we end up with the 17, right? And we end up with 2 minus 36. 17y is equal to negative 34. Y is equal to negative 2. So our solution, did we get anything else? We only have y so far, so we need to find the x, right? So let's plug that in. So I already know that x is equal to 3y plus 12 over 2. But if y is negative 2, that's 3 times negative 2 plus 12 over 2, which means that x is equal to what looks like negative 6 plus 12 over 2. X is equal to what looks like 6 over 2, which means that x is equal to 3. So our solution would have been 3 negative 2. And we should have that here. Yeah. All right. Woo. Good stuff, people. All right. So here's the thing. And one of the things that's going to happen. I'm not redoing this. I'm sending this out as is because you need to see the kind of mistakes that you can make. We're doing this off the cuff, so it will happen. And what I need for you to do is to be comfortable and to know that everybody makes mistakes in this instance. All right, so be comfortable with the idea of substituting and eliminating, and understand that when you're doing that, what you're doing is you're finding a point of intersection for these two lines, right? The point where they cross. And in so doing, you're finding a point that satisfies both equations. You're solving both equations simultaneously. Now I'm going to put this out there again. Follow up with the rest of the videos. Definitely like and subscribe. It helps keep this going. And visit the website. There is a website there. I will, and it's linked on the actual YouTube channel.